Hi there. Today we are diving into LangChain, a powerful library that makes working with AI easier and smarter. If you ever wanted to build an AI application and felt overwhelmed, this is for you. Let's start with the basic. But before that, let's first check the demo that we are going to build today. Let's run the application that we built using Python and LangChain, and which interacts with our local Ollama server. I will say Python, the package name that we have, and the class name. And we will run it. Then it says it asks for input, right? I will say hi. It will tell me, yeah, this is responded from the LLM, right? If we go to our Ollama server, it will make a request to API chat. It gets the response and it gives us. Now we'll say, how are you? How are you today? Now, I'm functioning properly and ready to assist you with any questions and tasks you may have. How about you? How is your day going? Going good. What's on your mind today? Write a simple, write a Python program to print 1 to 10. And it makes an API call again to Ollama local server. It gives us the program. Yeah, this is the Python code that it generated and it gave us, right? Now, since we have seen what we are going to build today, now, why LangChain? LangChain is a data framework that simplifies how we use AI model by organizing all the pieces needed to create an intelligent application. It is like a toolbox which helps you combine LLM, memory, tools seamlessly to create an AI application. LangChain isn't just another library. It is a framework designed to simplify working with large language models. It handles tasks like text generation, question answering, and many more, making it accessible to everyone. Now let's understand the architecture of LangChain. LangChain organizes its ecosystem into different packages like chat models, tools, memories, retrievers, and many more. Now each package focuses on solving a specific problem and they all work together to power up your app. The LangChain framework consists of multiple open source libraries. LangChain Core, which provides the base abstraction for chat models and other components. LangChain, it contains chains, agents, retrieval strategies that make up an application's cognitive architecture. LangChain Community, these are the third-party integrations that are community maintained. And there is LangGraph. It is an interesting one because it provides stateful orchestration framework to build agent workflows, which combines LangChain components into production-ready application with persistence, streaming, and many other features. Please subscribe to the channel so you get notified when I upload a lesson on building an AI application using LangGraph. Now, let's quickly look into some of the important components of LangChain. First is chat model. These are AI models that work like chatbots. They take a series of messages as input and give you a response as a message. Then what are messages? Messages are the building block of communication in LangChain, like sending text back and forth. They represent both what you say to the AI and what the AI responds to you. Now there is something called chat history. Chat history is just a record of your conversation stored as a sequence of messages. It helps the AI understand the context of what you are talking about. Now there is this structured output. Sometimes you want the AI to respond in a specific format, like JSON maybe. LangChain makes it easy to create this structured output so the data is well organized. There we have memory. Memory lets the AI remember what you said before, so it can use the knowledge later. This makes conversation feel more natural and connected. Then one of the main components I can say is runnable interface. Sometimes this is like a backbone of LangChain, right? It connects all the parts together so you can build workflows like plugging in Lego boxes and streaming. Sometimes we want the responses to come word by word instead of all the responses at once, right? This is where LangChain's string functionality can help us. Then we have this LangChain expression language. LangChain expression language is a simple syntax for chaining the LangChain components. Think of it like writing a AI recipe of all AI workflows. Means you have the LLM, you have the input, you want the output in this format. You chain all this together and create a LangChain expression language. And there are many more like document loader, text splitter, embedding models, vector stores, retrievers. We are barely scratching the surface of LangChain here. Now let's see how to set up a small application which takes a user input, then we pass it to LLM. Before passing it to LLM, we will construct a LangChain expression. We will pass it to LLM, we will get the response, and we will display the response. And this will happen in a loop. The moment you say bye, it will exit the program. Otherwise, it keeps expecting your input, like what we have seen in the demo. All right, so let's start building the application. I hope you have watched my previous lessons on how to install LLM in your local machine and using Ollama and how to use them. And also you might have already watched how to install Python, how to install intelliJ, and how to write your first Python program using intelliJ. If you haven't watched them, I strongly recommend to watch them before you build this app, because we are going to use Ollama from our local machine. We are going to use intelliJ. Yeah. So let's start building this app. First, I will open intelliJ IDEA. Then I have created a directory called LangChain app in my system. At present, I don't have anything in this. We will open this with intelliJ IDEA. I will click open and I will browse through and open that. And I will click open and it will be open. This folder will be open in my intelliJ IDEA. Ignore this .idea. It is internal to intelliJ and we are not going to do anything in this. Now, if you have already watched my previous lesson, you know that we need to have Python already installed. We need to create a virtual environment. We will install the libraries in the virtual environment and we will build the app, right? So first thing that we have to do is check the Python version. Yeah, so Python is installed in my system. If you haven't, please watch my previous video and see how you can install Python in your system. Now, next step is we will create a virtual environment. I will say Python -m venv is the command and virtual environment. Name of the virtual environment is .venv. I will say enter. And it created a virtual environment for me, right? The next step will be I will create a package. I will go here, file, new, and I will say Python package. I will give it a name of crack, break, make. I will say add. Next is I will go here, file again. I will say new Python file, and I will say LangChain assistant. Yeah. The next step, if you see, we have created a virtual environment, right? But we have not configured the Python interpreter yet. Either you can click here, it will open up this window, or you can go to File, Project Structure. Then you can come to SDK. In the SDK, we will click on this plus icon. Then we will do Add Python SDK from Dex. Then since I have already created a virtual environment using the command, I will do existing environment. I will click on these three dots. I will navigate to the virtual environment that I have created. So mine is inside lessons, YD lessons. Then I have this LangChain app that we created. Then I have this .venv that we created now. Then inside the bin, I will select Python version. And I will say OK, OK, apply, and OK. Then I have this class written for me. What I will do is, in the interest of time, I will copy the code that I have given here. And I will paste it here. Now, if you see, we know what library we are going to use. We are going to use LangChain, right? But before we do that, we have to activate the virtual environment. So we can install the libraries in the virtual environment. How can we do that? We will say source.venv, the virtual environment name, bin, and activate. In your Windows machine, it will be activate with capital A. Then you can activate it. And next step will be, since we have activated, we will install, right? We will say pip install LangChain. And it will install LangChain for me. Once it installs, as it installs, what we need to see now is we have our Ollama server running. If you have watched my previous video, you know how to download Ollama, install Ollama, and pull one of the open source models and start the server, right? So let's say in my case, the server was not running since I installed using brew. I will do Ollama serve to start the server, Ollama server. But in your case, if you have downloaded using the download button, Ollama server will already be running. You don't have to do this step. I am doing it because I installed Ollama in a Mac machine using brew. Now, if you see, we have our LangChain installed here. Next library that we will need is pip install LangChain Ollama, and it installed this as well. So let's see what has happened here. SDK, let me select the SDK. I will say LangChain app. I went to project. I select the SDK, which is like the Python interpreter that we created. I will apply. I will do OK. Yeah, the errors are gone. And we have already installed now. Next step is running this application, right? Now, before we do that, let's see what we did here, right? So if you know Python, I'm saying that if I'm trying to run from this file, check this as a main file, right? This is a main file. Try to run this file. Then there is a main function. In the main function, what we have is a char Ollama. This comes from LangChain Ollama. And here I am saying that we will use Llama 3.1 lattice that we downloaded in our previous lessons, right? Using Ollama. We downloaded this model, it is in our system, and we have started the Ollama server. So we should be able to communicate with this model. Next is we are creating a sort of prompts, right? One is the system prompt. System prompt is like a set of instructions you give to AI. So it knows what persona it has to play and what objective it has, right? Next is human prompt. Human prompts are like input or a user input to the language model in the conversational context. Now, I told you that we will create a chain using LangChain expression language. So what we took is prompt. Prompt is like the instructions. Then we piped with the LLM, means we will take the instructions, pass it to LLM. Yeah, and we constructed a basic chain here. This is a basic LangChain expression language. Right? This is a basic chain which is created using LangChain expression language. Either you can call .pipe or there is another way to do it. You can use the pipe operator. This is the prompt. I want the prompt to be passed to LLM. So I use the pipe operator and it created a chain for me. Now this is one way, and the other way is you can call the pipe function of LangChain. And this does the same thing. It creates a chain, it takes the prompt, passes it to LLM. It created a pipeline for us. Now next step is we will take user input. We will see if the user input is one of this tree. If it is one of this tree, just exit. Otherwise, we will invoke the chain. This is where we pass the user query. We pass the user query to the chain that we created, right? What happens here is we are using this, we have this query, we are giving it to LangChain. LangChain in turn give it to our, invokes the Ollama API, give it to our language model which is installed using Ollama with the instructions that we have here, right? The system instruction, which is like, you are a helpful assistant, please respond to user query in a markdown format. Means if I ask you something, always respond me in markdown format. This was the system instruction that we created. Now it takes the user query, it takes the instruction, it feeds to LLM. LLM will understand that and it will respond. And once it responds, we will print it. Let's try to run it, right? We can simply right click and run LangChain application. And it is there, right? So what it says is, let's say you is like my messages, right? You are where did I printed it? Here. You is the user input, right? My messages, I will say hi. Then it goes to our Ollama server with the instructions and the message, and the LLM responds to us, right? Hello, how can I assist you? Tell me a student joke. It again takes the instruction and it responded to me in markdown format because I explicitly asked it to respond in markdown format using the system prompt template or using system prompt, right? So this is way now the possibility is limitless here, right? You can use the same idea and you can build your own app. You can give any message to it, like write a Python program to check Fibonacci series. It goes to LLM again. It goes to LLM again, and here we have our Python program, right? So what we did here was we hosted one of the large language models in our machine. We built an application which communicates to that large language model, and you get all the response from its knowledge, right? So if you see, the possibilities are limitless, right? If you want to maybe tell it to improve the grammar, if you want it to maybe write a blog for you, you can have this application and start communicating with it. Next step is I will say exit and I will close the application. So I hope you learned something new today. Yeah. So if you liked what we built, don't forget to like, share, and subscribe. For more tutorials, I will provide all the links, the notes, and the codes in the description of this video. See you next time. Take care. Bye-bye.